cosine rule says the derivative of cosine of x is minus sine of x. And so to prove this, we just, as usual, let f of x be cosine of x, that function. And then we apply the definition of the derivative f prime of x is the limit of h as h approaches 0, f of x plus h minus f of x over h. So filling everything in, we have f of x is cosine of x, so f of x plus h is cosine of x plus h, minus f of x, which is cosine of x, all this divided by h. Okay. And so to evaluate this limit, we're going to expand this out using the cosine sum law. So we have cos of x, cos of h, minus sine of x, sine of h. That's the cosine sum law. And we still have the minus cosine of x hanging out on the end. All this stuff is divided by h. So now, just like for the sine rule, we're going to do the same thing. We're going to put the two cosine of x's together, and then we're going to have this other term left over. So we're going to group together the cos of x terms and the sine of x terms. So on the left here, let's put the cos of x terms. Cos of x, cos of h, minus cos of x, and then that over h, and then, oh, minus here. And this term's left over, so we have minus sine of x, sine of h over h. So I'm just writing the terms in a different order, right? Just putting these two terms here and this one there, and I'm breaking up this into this big fraction into two small fractions with the same denominator. Now, using the limit laws, I can write the limit of a sum of two limits, limit of a sum or difference of two things as the sum or difference of the two limits. So I'm going to do the limit of the first thing here, and at the same time I'm going to factor out this common factor of cosine of x. So now I have this guy right here, and minus the limit as h approaches 0 of sine of x times sine of h over h. Okay. So I'm allowed to do that so long as break this limit of difference into the difference of the two limits, so long as both these limits exist, which we'll see later they do. And shouldn't write the limit. Next thing I should do is notice that in both these limits, here the cos of x doesn't depend on h, so it's constant with respect to h, so I can pull it out front of the limit. So I can write cos of x times the limit as h approaches 0 of cos of h minus 1 over h. Similarly, over here I can pull the sine of x out front, so I have sine of x times the limit as h approaches 0 of sine of h over h. Okay. And when we proved the sine rule, we did a lot of work to evaluate these two limits, which are both very difficult to evaluate, this one and this one. But the work, we did it already. So make sure you've seen the sine rule video. In that, we evaluated this limit using some geometry in the squeeze theorem, and we found that that limit was 1. And then we evaluated this limit by doing some algebra tricks to make use of this fact. And eventually we evaluated this limit and we came up with 0. So therefore, in the end, we took the derivative of cosine of x and we ended up with 0 times cosine of x minus 1 times sine of x. So that's minus sine of x. The derivative of cosine of x is minus sine of x.